The root test. The root test is similar to the ratio test, and it is well suited to series with general terms involves powers. The theorem. Let series AK be an infinite series and let rho equals the limit of the k root of the absolute value of the AK. Case 1. If the rho value is less than 1, the series converges absolutely. Therefore, it converges. Case 2. If rho is greater than 1, including the rho equals infinity, the series diverges. The last case, if rho equals 1, this test is inconclusive. Examples. Use the root test to determine whether the following series converge. Example A. The series of the term 3k to the third plus k divided by 8k to the third plus k plus 2. As you notice, the whole expression raised to the power k. Or we say ak is the term 3k to the third plus k divided by 8k to the third plus k plus 2, all raised to the k power. Find the rho, which is the limit as k approaches infinity of the k root of the absolute value of the ak, or the limit k approaches infinity as the k root of the quantity 3k to the third plus k, all divided by 8k to the third plus k plus 2 raised to the power k. The k root and the k power take care of each other. Then the limit simplified to be the limit of the expression 3k to the third plus k, all divided by 8k to the third plus k plus 2. As k approaches infinity, the leading term of the numerator is 3k to the third. The leading term of the denominator is 8k to the third. The limit of this expression approaches to the value 3 over 8, which is the value less than 1. For the value rho, which is 3 over 8 less than 1, we can say that the series converges by the root test. In this example, we have series in the form of 1 over 6 plus the quantity 1 over 12 to the second power plus the quantity 1 over 18 to the third power minus the quantity 1 over 24 raised to the fourth power and so forth. We write it in the general form as we see as 1 over 6 as the first term, the next term 1 over 12 as 1 over 6 times 2 raised to the second power, plus the third term, which is 1 over 6 times 3 raised to the third power, minus the fourth term, which is 1 over 6 times 4 raised to the fourth power. So we see the denominator as the product of the 6 and the k raised to the power k. And also the sign switched back and forth between positive and negative. We write it as the general series form. As this is the alternating series, it's going to be the coefficient negative 1 to the power k, and the term, which is 1 over 6 times the k raised to the power k. For k equals 1, the term is positive, then the negative one has to raise to the power k plus 1 for the index k equals 1 to infinity. As we see this series in a general form, we're going to find the rho, which is the limit of the k root of the absolute value of the ak term by using the root test. So the rho, which is the limit k approaches infinity, the k root of the absolute value of negative 1 to the k plus 1 multiplied by 1 over 6 times k to the power k. It's convenient that the k root and the k power will take care of each other, including the negative side there. the absolute value take care of the negative sign, then it becomes just the limit of 1 over 6k. Take the limit as k approaches infinity. The value of the rho equals 0, and the 0 is less than 1. By the root test, this series converges. In this example, we have the series of the quantity 1 plus 4 over k raised to the power k to the second. As we see ak in the form of 1 plus 4 over k raised to the power k to the second. With the property of the exponent, the k to the second means k multiplied by k, or we can rewrite ak term in the form of 1 plus 4 over k raised to the power k and also raised to the power k on top of it. Find the rho or take the limit as k approaches infinity of the k root of the absolute value of the ak. Then the k root of the quantity 1 plus 4 over k to the power k raised to the power k. 1 of the power k of the ak term cancelled, then becomes the limit of 1 plus 4 over k all raised to the power k as k approaches infinity. And you see the hint, the limit of the 1 plus x over k raised to the power k for k approaches infinity is e to the power x. In our case, the x is the value 4. Therefore, the rho equals e to the fourth power, which is the value greater than 1. If the value of the rho greater than 1, by the root test, we can say this series diverges.